Good morning, everyone, and welcome to the Lonza 2020 Plant Operator Seminar. I'm Grady Bradford, Lonza Industrial Sales Director, your moderator today. Before we get started, I'd like to go over a few items to assist in making participation in today's event simple. This is an example of the attendee interface. You should see something similar on your own computer desktop in the upper right corner. The audio defaults to your computer's speaker system. If you would prefer to join over the phone, just select telephone in the audio pane and the dial-in information will be displayed. You will have the opportunity to submit text questions to the presenter by typing into the question pane of the control panel, which you may send at any time during the presentation. We will collect these and address them during the question and answer session at the end of each presentation. I have a short statement for those from the state of California. Please note, to receive CEU credits, the state of California requires periodic quizzes throughout the day. We have set the quizzes to come through SurveyMonkey during all breaks of the seminar. If you receive a link from SurveyMonkey, please take the quiz immediately. I would like now to introduce our first speaker, and that is Eric Loomis, who will be updating you on happenings at Lonza. Eric is the Director for Commercial Operations for Lonza Wood Protection. He has 15 years of experience in wood protection, preservation business in research and development, manufacturing and production, and sales. Eric has a BS degree in chemical engineering from Auburn University and is an active member of American Wood Protection Association and the Western Wood Preservatives Institute. Eric hails from Louisiana, is an avid LSU fan. Eric?
Well, thank you, Grady. Welcome all again to the Lonza 2020 Fall Operator Seminar. Grady just introduced me, but Eric Loomis, for those who don't know me, I'm the Director of Commercial Operations for Wood in North America. Grady took out some of my background information, so I'm gonna have to skip through, and this will just shorten my discussion. But anyway, so Grady asked me to give a quick update on what is happening with Lonza. I think in a real short answer, I can say that it's just been a little hectic. Obviously, with the increased demand in the do-it-yourself world and the recent hurricanes in the south, it's been a really busy summer, and we've been just keeping our head down and making sure that we continue producing wood preservatives so that you guys can continue to operate. Of course, we don't have to tell you guys that because we're only busy when you are. So for our wood preservative customers on the line, I'm sure you know how busy it's been throughout the summer, and we appreciate you guys taking your time to attend this meeting. I saw there's several new attendees are not in the pressure treated wood market. So for a brief description, Lonza is a provider of EPA registered wood preservatives that provide protection against wood destroying organisms. No different than your standard pesticide license requirements, our industry requires CEUs to maintain our pesticide applicator licenses. So our format is going to be more focused on wood preservatives, the chemistries, the science of treating. So this webinar may be a little different than what you're normally receiving or training, but again, we tailor this and focus this to our industry, to our customer base, so that the education and the training they're getting is more designed or more tailored to their end jobs. So going back to what's been happening, not only has it been busy, but with the COVID-19 restrictions and regulations, it's created a different way for us to do business. So not only does it create an additional demand, a different way how we operate, but it's also created a necessity to change the way we do business. So that is why we're here today and in this format. For those who normally attend this, I'm not aware of us doing anything outside of us in person. So this will be the first time in our history that we're providing this training in a webinar format. And but it's needed, and we hope to and we're putting this together to continue to provide the service needed for you and our customers to to receive the required CEUs. We ask for your patience. This is a new format, and I'm sure there's going to be some hiccups along the way, whether it's internet connections on your end, our end, speaker changes. Please give us your patience. Let us work through this, and hopefully it will go as smooth as we expect. But be aware it is something that's a new technology, new format. We also want your feedback on the session. So the session, the content, the speakers, specifically for our customer base, our pressure treated customer base, what do you guys want to see more of? What do you want to see less of? There's certain things we have to educate you on just in order to receive credits, but we're constantly looking for different types of content, different types of feedback, ways for us to improve this experience for you to, if you're going to take your time, what type of things do you want to receive training on that we can hopefully get credits for. So please jot down those notes as you're going through the training. Please get that feedback to us at some point so that the next time, or maybe even during this training, we can improve on what we're offering. Finally, before I start, I want to say thanks to all the speakers and organizers, especially those outside of Lonza. We appreciate the time taken out of your normal schedule. And we appreciate the offering that you give to the industry. And then last, I want to specifically thank Sarah and Belinda for all the work that is used to, or that takes to set this up. For those who are not aware, there is a ton of extra work that goes on in the background in order to set this up. They have to make contacts to all the states. They have to give out all the agendas, make sure you guys are registered. So it's a lot of extra effort, and so next time you see them or talk to them, please thank them and let them know you appreciate them. I surely do. I understand there's a lot of work. I'm just involved in a few of the meetings, but there's a lot of people, a lot of work in order to set this up. So with that, I want to thank everyone again for attending. I hope this is a good opportunity to learn something about the wood preservative industry that you didn't know. I typically sit through 2 or 3 of these a year because I have to have credits as well. And normally I learn 1 or 2 things before that I seem to have forgotten over the years. So please pay attention. And again, we appreciate your attendance. With that, I'll turn it back over to Grady to introduce the next speaker.
Thank you, Eric, for that presentation. You were quicker than I expected. Our next speaker is Jeff Miller. He's the keynote speaker. Jeff has served as president and executive director of the Treated Wood Council since 2003, where he focuses on government affairs, financial growth and management, membership growth, and much more. Jeff earned his BS degree in chemical engineering from the University of Notre Dame, his MS in civil environmental engineering from the State University of New York at Buffalo, and his MBA in management from Fairleigh Dickinson University. Jeff will be talking to us about Treated Wood Council. Thank you, Jeff.
Thank you, Grady, and welcome everybody. We want to spend a couple of minutes here just chatting about the Treated Wood Council itself. Many of you probably are familiar with the council and who we are, what we do. In fact, if you're operating a treating plant, you have to comply with regulations, and they might be state regulations or federal regulations. They might be specifications given to you for your products, either by the Corps of Engineers for their applications. It might be specifications from state departments of transportation. If you sell products that go into the DOT markets. But the important aspect here is that every single plant has to comply with external regulations and specifications in order for you to operate properly, in order for you to operate within the laws and the regulations of the state that you live in. It's important then for you to understand a little bit about the Treated Wood Council and what we do. Let me just ask there we go. A little bit of the story behind the Treated Wood Council. It's got its start in 2002 with a group of about 20 or so organizations sat down together. They started thinking and talking about government regulations, EPA, OSHA, congressional activities, state legislatures, and some of the agencies that I talked about earlier. And these initial organizations, and one of them was Lonza, were concerned that there was no organization out there that was, let's just say, guarding the henhouse, keeping track of what EPA does, what kind of regulations they come out with. They wanted to make sure that there wasn't something proposed or enacted that would either put you out of business or make it so expensive that you couldn't comply with those regulations or eventually price you out of business. In that group of the 20 or so companies that started, I divide them into three components. They were the preservative suppliers like Arch Lonza, other companies out there that provide preservatives. They were wood suppliers, sawmills basically, and pole yards that manufactured the materials that you purchased, as well as the preservatives that you purchased. And the third component were the treaters, you folks, the people that buy those two products, put them together, and sell an end product to the customer and the end consumer. Today we have grown from starting with about 20, some 17, 18 years ago. We now have over 500 member organizations. And most of you who are on the line today are members of the Treated Wood Council, and we thank you for that. There's 182 treaters who are members, 126 wood suppliers. And last week, our board of directors elected another wood supplier. So there's actually 127 now. There's 11 preservative suppliers, and they include borates and oil-borne preservatives and creosote and all of the waterborne preservatives, all those products that you folks use. And then there's a group of 190 or so associate customer members, as well as association members. I'll get into that customer member category a little bit later on, and we could talk a little bit about that. I could explain to you where we are with that one and where we're going. We have one main task, and that task is to protect and expand the uses of treated wood products through government affairs activities. So let me give you a couple of examples. If you have stormwater runoff from your property, you have to comply with certain stormwater regulations. If you fill out TRI reporting forms for the EPA, again, you have to comply with regulations. If you have air emissions, or if you have regulatory requirements for the operation of your drip pad, all of those are regulations promulgated by certain bodies, usually EPA, that affect the way you operate your plant. The job of the Treated Wood Council is to monitor and communicate with EPA, with OSHA, with state agencies, with Corps of Engineers and state DOTs and legislatures, again, to make sure that those regulations are fair and they're doable from your standpoint. We're going to get into some of the active programs going on right now as we move forward. But that's the mission of the Treated Wood Council. That's who we are. That's where we've grown to in today's environment. I will mention to you that I communicate with our members almost daily. I do it by email. Some of you receive those emails, some of you may not. If you do not receive those emails, and if you're interested in receiving them, please let me know, or send a chat, send a note, say you'd like to receive them. We'd be happy to add you to that email list and keep you up to speed on things that are going on that might affect you directly, both in terms of operation and in terms of markets. Let's move on a little bit to some examples of things we do. A couple of things on the federal regulatory agenda. EPA, I simply call it NESHAP. NESHAP stands for National Emission Standards of Hazardous Air Pollutants. They apply to plants that use penta, or they use an arsenic-based wood preservative. EPA was sued over those regulations. They will govern how you operate, how you might have some kind of air emission from your plants. For you folks, most of you might have an arsenic-based preservative, either ACZA or CCA. Eventually, EPA will come out with some regulations regarding those operations and how you folks need to comply. So we're involved, we're engaged with EPA, we're communicating with them. We've already sent them some information on plants that use CCA and use penta, information that they don't already have, and updating those things. So eventually, sometime in the middle of next year, 2021, we're going to see proposed standards for air emissions from wood preserving facilities. That's something that's on the agenda. I mentioned stormwater. The next item here is stormwater. EPA has a guidance program for industrial stormwater discharge permits. Most of those permits are issued by state agencies, but those state agencies go by what the EPA includes in their guidelines. So very simply, we have communicated with EPA. We have asked them to consider certain issues with respect to stormwater discharge. I'll give you an example. Most stormwater discharges occur, obviously, when there's been some precipitation. Interestingly enough, EPA has established those guidelines in the past based upon low flow conditions. Well, low flow conditions don't often apply with precipitation conditions. So part of our communications, and that's an example that I give to you, is to educate EPA on adjusting those stormwater permit guidelines to consider wet weather conditions and not dry weather conditions. So we're in the middle of that particular activity as well. Sarah, can I get this slide to go backwards?
Yes, hit your back button.
Yeah.
I'm getting it to go forward.
Use your arrow keys. It'll take you back.
Okay.
I have to let go.
I got it.
Hey Jeff, down in the bottom left-hand corner, you should also see some arrows, and you'll be able to move the slides back that way as well.
No, I can't get it to go back. Sorry.
I'll do it.
Thank you.
I say I'll do it. Here?
That's good.
Okay.
Thank you. Apologize for that.
Well, there's going to be glitches. We got this.
That's all right. Other federal regulatory activities. The Non-Hazardous Secondary Materials Rule, NHSM, is another rule that we have actually petitioned EPA for changes. And those changes will allow, if EPA adopts them, and we believe they will eventually, it's a what we would call a change in the framework of what you do with treated wood at the end of its useful life. It's not an operating rule for a plant. However, it affects our sales. If we can convince EPA and then the public that used treated wood, let's say MCA treated wood, at the end of its life can be used as a boiler fuel, then it becomes a fuel source rather than a waste source. This is a petition that we have before EPA, one that we've initiated to change that criteria. The courts have ruled in our favor on this particular issue. We continue communications with EPA, and we've been told that a proposed rule will be coming out at the end of this year. Next on the agenda is the plywood set of standards for emissions from kilns. Some of you might have lumber kilns that you kiln dry after treatment. And this is a set of standards that EPA is going through right now. We have been engaging them. They have questioned us early on with respect to the operation of those kilns and how to reduce emissions, particularly methanol, which is a hazardous air pollutant. The early discussions with EPA centered on some type of an engineering control for a kiln. An engineering control would be a hood or some kind of ductwork that would capture the emissions and then send them to some sort of a treating plant. We have convinced EPA that that's not necessary, that management standards such as regular inspections, measurements for wet bulb temperatures, measurements for wind speeds and velocities and operations of fans and motors, and documentations of those inspections are all that's necessary. None of us want to have a kiln that's not operating correctly. That costs us money. We have a financial incentive to make sure that kilns operate correctly, and we simply want to have a system of monitoring those systems, of documenting what we do, and then that becomes the standard for controlling emissions. A little bit more about federal regulatory activities. The Corps of Engineers, I mentioned that to you earlier. The Corps of Engineers, in its many district offices all over the country, issues what are called general permits. And general permits govern the construction, the maintenance, the operation of structures that are in or near waterways. So if somebody wants to build a dock, or they want to build a retaining wall along a bank, if they want to build some pilings or put in some dolphins, they have to go to the Corps of Engineers. Most of these fall under a general permit. And we have found, as we've searched through Corps of Engineers permits, that a small percentage of them, 10 to 15%, all over the country, have restricted the use of treated wood products. We have gone into some of those, California, Missouri, Arkansas, and other states, and I've listed those there. And we've actually changed the language in those general permits to allow the use of more treated wood products. We are actively involved in another 6 or 7 states on permits that are up for renewal. And those permits would have restrictions on treated wood products for use. Our efforts there are to change those like we have in those other states listed. So it's a positive measure that helps to expand markets for treated wood products. The same has to go with the next item, which is the Department of Agriculture, the Rural Utility Service. That is the service that helps guide rural utility cooperatives. And cooperatives are groups of localities, of cities and counties that get together, they organize a cooperative, and they provide utility service to those rural counties. Much of that has to do with utility poles, with cross arms. We're involved right now in rewriting a technical guide for the rural utility service to allow and to specify more uses of treated wood products, both poles and cross arms, in those cooperatives. On the federal side, I want to talk a little bit about congressional activities. If you read the newspaper, you find out that Congress is quite polarized these days. They're involved in all kinds of issues that pertain to social activities, financial activities, taxing activities. And luckily, in the last several years, we have not had a abundance of federal legislation that impacts the treated wood industry directly. However, we do use congressional representatives to communicate with EPA. I talked before about the petition that we had before EPA to change the framework of treated wood biomass once it goes out of service to be a boiler fuel. We've actually used 4 members of Congress to write letters in support of our petition in that effort. And all 4 of those members of Congress we went to because they've gone to our facilities. They've visited our member plants. In 2019, we had 19 congressional visits to member facilities. I have a list of them there. Several wood treaters, Blue Links up in Duluth, Minnesota, Marks Miller in Montana, Central Nebraska, both in Nebraska and also in Iowa. Beaver, Madison Wood Preservers, and Culpeper in Virginia. It's an important aspect of our business to bring members of Congress in, to educate them about the treated wood industry, what we do, the products we serve, the benefits that we provide both to the local community as well as the general public that are the consumers. We've had 6 of these congressional visits so far this year. All of those occurred in January or February before the slowdown of travel and restrictions on visitations went into effect due to the virus. This will start up again after the elections. Hopefully we'll bring this back in. First of all, I want to thank all of the members of TWC who have participated in this program. If you have not, if you're interested, please let me know. Couple of international activities in Canada. Environment Canada for climate change is right now undertaking a risk assessment, environmental risk assessment for copper and discharges of copper into waterways and also into the air. We've engaged this activity through the Copper Development Association here in the States, as well as Wood Preservation Canada out of Ottawa, providing information to them, waiting to see now what their first response will be to our comments. More importantly, things like this that happen in Canada become the basis for initiatives in the United States. So our efforts here are aimed at securing a fair assessment, an accurate assessment, and one that, if it does come to fruition, we're going to see some positive measures there with respect to wood preservation, the use of copper as a wood preservative, and then something that EPA can actually use to our advantage. SIGRI is an international utilities organization. They're in the middle of examining treated wood utility poles, specifically CCA poles, on an international basis, trying to decide how they should be specified, how they should be installed and remediated throughout their course of life, and at the end of their life, how they should be removed and disposed of. What they come out with in this particular study will affect international markets for poles, as well as ultimately US applications and specifications for utility poles. I've listed here several state activities that are going on. In Georgia, we have a ban on the use of railroad ties for cogen facilities, and we've been actively involved in that particular piece of legislation. Right now, it focuses on creosote and copper naphthenate ties, but certainly could be expanded to any type of tie that's out there. And then ultimately, any type of treated wood that might be burned in a boiler. In New York State, there are 3 pieces of legislation that we've been tracking, all of them introduced last year. Each of them we have submitted comments and contacted the sponsors. One that would pertain to the use of penta on transmission poles, one that would phase out the state use of pesticides, and a third one that would ban creosote treated railroad ties. And as you folks probably already know, about 90% of all ties are creosote ties. There's legislation in New Jersey, Arizona, and Montana that would label pentachlorophenol as a narcotic drug. I won't get into that in too much detail, but it's a labeling issue that we're trying to avoid. In Florida, legislation has been introduced affecting or targeted to a non-closed down CCA pole treating plant in Jacksonville. And the legislation would provide $100,000 to each employee, ex-employee of that treating plant. And the claim in this legislation is that the operators of that plant and the owners did not follow proper protocol when it came to safety and education of their workers. This particular piece of legislation doesn't seem to be going anywhere, but is a terrible precedent for the wood treating industry, especially those using CCA. I mentioned on that last bullet point now, 7 or 8, 10 states or so that have legislation that would ban the use of a neonicotinoid pesticide. And one of those pesticides is imidacloprid, which is used by many of you to treat dimensional lumber that could be used in indoor or protected applications. It's a bad piece of legislation. We've communicated with every sponsor, and we continue to oppose this type of legislation. I talked about state departments of transportation. I don't want to get into each particular state in detail, but I simply listed there all of the states that in this particular year, we have engaged with them on specification work involving treated wood products. They're all over the country. Some of them specify, I think you might be familiar with AWPA standards for treatment of wood. In 2008, AWPA changed their standards from a C standard to a U standard, U meaning for use. Half of those states listed there still cited specifications referring to AWPA C standards that were done away with in 2008. Many of these do not include all of the different preservatives that are new preservatives on the market. Some of them do not include MCA as an acceptable treatment preservative for dimensional lumber. So our job is to go into those states, clarify, rectify what they're doing, educate them about treated wood, and in the same process, get them to use more treated wood. I said I'd get back to this one, and I'm sort of near the end. 2 years ago, we expanded our membership category to include major customer members. The major customer members are railroads, big boxes, utilities. We've added several big boxes to our membership ranks. Lowe's, 84 Lumber. We're working on Home Depot. We have several utilities that are members, several railroads that are members. We just think it's important to bring those folks to the table. They are our customers, our major customers. We need feedback from them. We need to understand what their concerns are. The more we can get them involved, the better we can operate, and the better we can satisfy their needs and their demands. If you folks sell to a utility or a railroad, or you sell to Home Depot, we'd love to have you help us out to get them to join Treated Wood Council. Lastly, we have an annual meeting coming up. It will be November 19th and 20th. It will be a virtual meeting. It will include speakers from government. It would include a board of directors meeting as well as a government affairs committee meeting. It will start around 11 o'clock for you West Coast folks. That's 11 o'clock Eastern time, and proceed through the morning and then the early afternoon on both the 19th and the 20th. We cordially invite you to join us at that annual meeting. Later this week, I will be sending out the formal invitations to register. Thank you very much.
Well, thank you, Jeff. Did anybody send in any questions, Belinda?
I don't see any questions. You should be able to see them too, Grade, now.
Okay. Well, I don't see any, so let's move on. Thanks, Jeff.
Thank you.
Our next speaker is Micah James. And Micah is a technical sales and service representative. Whoops. I think I'm supposed to be on here. Micah is a technical sales and service representative with Lonza. He's been in the wood protection business for more than 18 years with positions of increasing responsibility, beginning in the pilot plant as a pilot plant technician, and most recently handled sales and technical services. Micah has a bachelor's degree of science in biology from Georgia State University. He is a member of the AWPA and also serves on the T7 Technical Committee. Micah will be speaking with us about pest identification and management, particularly the common enemies of wood and protecting it. Welcome, Micah.
Thanks, Grady. Good morning, everyone. Just to correct that last statement, I'm no longer on the T7 committee for the AWPA, but no worries. I'm going to talk a little bit, a brief kind of general overview of the enemies of wood. So with degradation, you know, you have that with any type of sorry. There we go. With any type of material, spalling concrete, metal corrodes. So, you know, with wood, we still deal, or with all materials, we still deal with those, you know, with other issues. When we talk about degradation or enemies of wood, there's non-biological and biological attack or degradation. Specific to the non-biological, you can have mechanical damage, you know, weathering by UV, the sun, or moisture, chemical heat damage, to mention a couple others. Mechanical damage caused by rain, wind, cleaning, traffic, anything that's it removes sound or degraded wood fibers. I've seen this on decks, heavily used stairs where the front of the stair, each step is a little worn. I think we've all seen this. Really, you can only put a mechanical barrier to prevent. I'm sure everyone's seen UV weathering or sun damage to wood. It leaves it a gray look, wears away some of the material. It's usually non-destructive as far as structural integrity. Moisture problems, that's typical for well, any woods really. Dimensional change, warping, bowing, cracking, splitting, checking. This is a common occurrence in treated wood products and happens due to moisture moving in and out of the wood. It can be slightly reduced by surface coatings or pressure applied water repellents, but typically there's not much you can do unless they're completely protected from the elements. The chemical degradation, yeah, I think we don't really typically see this, but you can have strong alkalis that degrade lignin and the wood becomes fibrous. Strong acids degrade the cellulose and it becomes brittle. Prevention by the use of more resistant wood or external barriers. Again, I don't think this is a very common thing, but it is one of the things that can degrade wood. Heat, decomposition begins above 100 Celsius and combustion above 275. I read an article that you can actually decrease that combustion temperature the longer exposure to heat you have. Typically not an issue seen, but it was an interesting article. Degradation dependent upon moisture content and duration. It results in color change and strength loss. I think everybody understands heat or fire, but we can use thermal barriers or fire retardants to pressure treated fire retardants to prevent heat or fire degradation. So when we get to biological, that's the main thing we are looking to prevent, specifically fungi, insects, marine borers, and maybe some of the other things, but not so much. So mainly, of course, our attention goes to fungi. Mainly with fungi, you have wood decaying fungi, which is what we try to prevent with our pressure treated products. You also have non-wood decaying fungi, which are mold and mildew, sap stains, things that don't typically structurally affect the wood, but are aesthetically unpleasing. With wood decaying fungi, they are living organisms and they require 4 things. Source of food, which is the wood itself, moisture, oxygen, and the right temperature. When we treat wood or apply something to it to preserve it, we are attempting to remove one of these things. But, come on now. So when you see a decay fungi, if you actually see the fungi, which is usually accompanied by mold growth too, but it is still visible. It's the fruiting body. That's where the organism is trying to reproduce and spread spores to other areas, other wood that's, for reproductive purposes. The destructive part of decay fungi is in the microscopic filaments that grow into the wood. It's called hyphae. I think of it like roots growing through, in between, and within the cell of the material of the wood. With that growth, it excretes cellulase and other compounds that digest the wood. So it's actually excreting these chemicals, breaking the wood down, and then absorbing nutrients from it. And that's all they're trying to do. They're just trying to live. This is a healthy cell electron micrograph of the cell walls and cells of a piece of wood, structurally sound. And here's another one that shows the destruction that occurs after decay fungi are consume whatever they consume. When you talk about the three types of rot or decay from the fungi, it's mainly brown, white, and soft. Typically, in my experience with treated wood, if you have a problem, it's brown. Those are more hardy, more hard to prevent. You still see white rot, typically out in the, to me, in the woods. You kick a log that's fallen and it's, rotted. You see it kind of, to me, that's more representative. It's white in color. Soft rot is not usually a big degrade, but it's still prevalent. Sorry. Brown rot, it attacks cellulose and hemicellulose, so it causes the wood to turn brown. You get that cubed cross grain checking, and it crumbles easily. It's predominantly decay in softwoods. You typically get faster weight and strength loss. With white rot, it's attacking mainly the lignin. It turns the wood white and fibrous or stringy. It's more prominent in hardwoods, slower but more complete weight loss. Soft rot, it attacks all components, but it's limited typically to the wood surface. It causes a darkening, it softens it. Typically, it's in conjunction with another type of rot. It usually just reduces that surface of it and then allows other things to infest it. Mold, we're still talking on fungi. Mold is a type of fungi, but it's just surface growth. Mold spores are everywhere. Everywhere we breathe, outside, inside. If they land somewhere and like where they land and have all the components needed, they will grow. With treated lumber, we have that problem sometimes. That's why we introduce additives, as in moldicides, to help prevent those. But really, it's just a aesthetic issue, or maybe somewhat of a health issue to not have a lot of active mold spores available. So we introduce these things to help prevent that between the time of treatment and the time of consumers purchasing the material. You still see it on untreated material, but it's just feeding on the surface, it doesn't affect the strength. Everybody's seen mold, I'm sure. Sap stains, similar, but they do not usually produce that very visible fluffiness like mold. It grows throughout the wood, through the cells, and stains it. That's why it's typically called sap stains. Again, doesn't really affect the strength or the material itself, just an possible aesthetic issue. It typically grows through the sapwood of unseasoned soft and hardwoods, has the pigmented hyphae, that's why it looks like a stain. It uses some food stored in the wood cells, so that's instead of degrading and breaking down, it's just using food that's currently there. It's significant because it's rapid growth, but again, doesn't cause any problems, just a staining look. I'm sure we've seen this, or some of us may have. That's blue stain. So when we talk about protecting against the fungi, specifically the decay fungi, we need to eliminate one or more of those needs, the food, water, oxygen, or heat. So our main focus is applying pressure treatment preservatives. That eliminates the food, right? That eliminates the wood as a food source. There's still going to be water, oxygen, temperature enough for it to grow, but we do that and we prevent it from growing. Another option, dry wood less than 20%. That's great, but not for exterior use. It's going to get above that during times of the year. Keep wood saturated completely. That works too. And apply heat. Typically that's done when things are sent. You have to follow requirements for wood that's like pallets sent overseas have to be heat treated to make sure it kills everything before it's sent. We don't spread things. Just a couple of oxygen reducing techniques. You may have seen this, log yards with water spraying or floating. Obviously this is transportation too, I think in some sense, but you do see they stay wet, they don't degrade, the fungi can't get in there. So when we get to another biological attack that we try to prevent is wood destroying insects. Termites, carpenter ants and bees, beetles, to name a few. I'm sure we've seen pictures of termites. They live in structured colonies. They consume wood. The galleries include frass, which is basically their excrement, but it looks like sawdust. With termites, they're kind of interesting, and if you find them in something, there's typical. You should be able to notice that it's very difficult to notice, but they make these paper galleys going up concrete to get to the wood. They like higher moisture and higher carbon dioxide levels. So, and then if they're in, it's hard to find them in a piece of wood sometimes because they will get to the edge. It's just making a little hole. They see out of it, they turn and go the other way. Formosan termite is an especially destructive type of termite. The hazards change based off of the environment. Typically, you see a heavier presence in the southeast the southwest there, due to temperature and moisture. And then it's only moderate to heavy in that area, slight to moderate as you go further north, and then none to slight. Again, based off of mainly temperature where they stay. So when we talk about carpenter ants and bees, they do not consume the wood. They just infest it. They're using it to live in. If anybody's got a deck, at least in the southeast, it's a constant battle with carpenter bees, at least at my house. So it is something to, they don't do it, unless they really infest, they don't do a ton of damage. Usually you see them before that and you can take care of them. Really the only way is a physical barrier. Very few treatments are effective because they don't consume the wood. The carpenter ants, they're just, again, using it for a home. I moved about a year ago and these are in my front yard. It was interesting to see all of the things here moving into kind of the woods. This guy was on my back patio. When we talk about beetles, another wood destroying organism, there's ambrosia beetles, metallic wood boring beetles, powder post beetles. And I think this is a metallic wood boring beetle. So they're prevalent in the area that I am in, here in Georgia. The ambrosia beetle can attack freshly treated wood. It doesn't hurt them. That's a typical galley scene that's common to the ambrosia beetle. A buprested beetle. That's a metallic wood boring beetle. When you see the size, I didn't have anything to do the size of that other one, but it was about that same size. But again, they'll infest trees usually, can damage forests if there's droughts, because the trees are already stressed. So then it can, you usually see population blooms of different, insects like this when in times of drought. New house borer can survive pressure treatment. Powder post beetle. This looks like, I think it's a piece of oak, but it's, been attacked. I've seen this more common probably than the other ones. Prevention, again, chemical treatments containing insecticides to the ones that consume the wood. Physical barriers, ponding, sprinkling, wire mesh, painting sometimes, depending on the type of paint, or heat treatments, of course, can kill them, but it can't prevent reinfestation. Then we get to marine borers, common problem further south, similar to other insects. You have more of a problem where it's warmer, of course, in the water. The main ones, shipworms, pholids, and limnoria. I believe these are shipworms, and I think this is both, or all three maybe. Shipworms are long translucent worm-like mollusks found in all U.S. coastal waters. To me, the interesting thing is, as they bore through and live in the wood, they leave like a calcium carbonate lining on the inside of these, the openings. You can't really see it from the picture, but that is a typical shipworm infestation. They use the wood for food. Pholids clam-like mollusks found in coastal waters. They use wood for shelter, and they can actually bore into anything, any substrate, concrete. The tip of their shell is really sharp, and they rotate slowly as they grow and make themselves more comfortable in the matrix that they're living in, whether it's wood or other things. It's very hard to get rid of those, almost like a physical barrier is needed. They're filter feeders. They don't consume the wood, so they're just in there for a little home, and they protrude their little filter, their tentacles out to feed in the water column. Limnoria, pill bug-like gribbles, that's a common term, crustaceans found in all U.S. waters. They use water for shelter and maybe food, and can reinfest wood. This is that hourglass pattern that you see on piling. Within the tidal zone of the piling, it will lose mass and lose substrate right there, giving it an hourglass appearance. A lot of times these things attack at the same time. You'll see a folded hole and then a shipworm, like in addition to it. Prevention treatments: CCA, ACZA, creosote, or dual treatment, or physical barriers. It is somewhat difficult to prevent these infestations, but at the right treatment, you can do it successfully. Bacteria, we have some of that, but usually it's in addition to fungal attack. So usually don't see it. It's a slow degrade. It's typically saturated. Sapwood is most susceptible. And of course, just birds and cattle, just general cattle, horses chew on the wood. Birds, woodpeckers will degrade a pole, but again, that's really irrelevant of the treatment. But and then of course humans do good enough on degraded wood too. So, but anyway, thank you. If you have any questions, let me know.
Thank you, Micah. I don't have any questions popping up. So we'll move on to the second part of pest identification and management. And that will be Tim Carey speaking with us about using preservatives to protect wood. And Tim is Lonza's industrial sales specialist and has been with Lonza since 1996. He provides support to customers, manufacturing, and users in all areas of treated wood, including production, quality, process, and proper end use. Along with serving customers, Tim has had several articles published in technical journals and serves as the industrial representative for SIGRA. He is active with many industry associations, particularly AWPA, SPTA, TWC, and ANSI. Tim received his undergraduate degree from the University of Georgia and his BA in management from Georgia State University. Tim?
Thanks, Grady, man. Good morning. A lot of what I'm going to talk about, we all know. Hopefully I'll help you learn a thing or two, as we talked about earlier, about some things, or maybe just kind of bring some stuff back up to make you think about stuff. Come on. Not moving forward here. All right. If you think about it, tree types grow in the environment where, as treated wood, they have the best opportunity to provide the long-lasting service life. You've got thin sapwood species on the west coast where you don't have as much decay and insect problems, and thicker sapwood in the southeast where you can put more preservative in. So the level and type of treatment that is applied is based on these environments and the end use. And as Micah talked about earlier, wood's not the only thing. Sometimes people think that these alternative products are perfect and they have no issues and no maintenance needs. But as you can see, we have spalling concrete, we have fiberglass delamination, you have aluminum crinking, and even underground, which is always considered the perfect situation. If you get a hurricane and it blows it up out of the ground, it doesn't help much, and steel, as we all know, can corrode. But we also know that wood is almost the perfect material. If it's taken care of and put in and dealt with properly, it has a long service life and all kinds of applications. So, I mean, most of these uses everybody's familiar with, whether it's a dock assembly on marine use, whether it's decking, utility poles, construction, and railroad ties. So here's where it all started. I don't know about you, but when I was growing up as a kid, my grandfather used to keep a barrel of used motor oil around, and we would heat that thing up and put fence posts in there to treat the sapwood of the post to make them last longer, especially when we couldn't find enough black locust posts to use. So that's kind of the way a lot of this stuff started. You're talking about soaking, impregnating, putting it in a freshly cut wood, hoping that it will absorb it up. But you don't get a real good envelope of protection from that perspective. Then in the 1830s, pressure treatment came along, and it was all done by the full cell process, and it was mostly all done with creosote. And in this case, we're talking about the Bolton process, which is kind of an interesting thing in that what you do is you take green wood, you put it into a cylinder, you introduce the actual heated preservative itself to drive off the water from the wood that is then removed by vacuum. The nice thing about this is that you're actually adding preservative in the conditioning process before you actually pressure treatment. So it was a good way to treat a lot of early materials. The industry started growing with the growth of the railroads, and also with once developing things. And then from that, there came a need for organizations to exist to help people determine how to treat, what are good preservatives, what are good results of preservatives. And that's where the AWPA came along in 1904 in the U.S. Forest Products Laboratory at the University of Wisconsin as part of the U.S. Department of Agriculture. We have a number of types of preservatives. Oil-borne, they have creosote listed here, but creosote acts like an oil-borne, although it's a little bit different. Obviously, pentachlorophenol, copper naphthenate, copper 8 quinolinolate, and the latest oil-borne is DCOI. Waterborne preservatives you have here are listed: CCA, ACZA, ACQ, the copper azoles dissolved and micronized. We have some metal-free, and then there's some other ones that are out there too. When you talk about creosote, it's a restricted use pesticide, or RUP. It's continued to be used in the U.S. It's the dominant on hardwood railroad ties. It's also used in poles, piling, and bridge construction. You can put it in contact with the ground, fresh and salt water. And also you can incorporate borates with it, either as a pre-step or as a one-step option. And that just further penetrates the area within the heartwood of the hardwood ties, which are so difficult to treat. Pentachlorophenol was developed in the 1930s and was originally developed as a soil sterilant. Then it was found that it could actually be applied into wood and used as a protector of wood poles. KMG is the sole supplier for North America. They manufacture it in Mexico. It's used for poles, cross arms, piling, bridges, ground contact, and some freshwater use. Current manufacturing is set to end at the end of December of 2021. There have been talks of others potentially doing it, but no one has a plan in place. So it's going to be, I think, very difficult to achieve that for someone else to get into the business. So you're going to see some other opportunities for other products to come into its place. Some of the other oil-bornes that are out there that you probably are aware of is copper naphthenate. It's been around a long time. It's used for treat a lot of different things. It's a unclassified preservative. Same is true with copper 8 quinolunolate. It's the one of the preservatives is approved for food contact. So a lot of crating for food is put in there. It's used in log homes and in-cut solutions, as is copper naphthenate. So it's typically not a pressure treatment, but it is something to use for different things. I know for log homes in particular, they have stains in it, so it can be different colors. DCOI is the newest one, and it's still in its infant stage of development and use. So we'll have to see how that one goes about forming. Waterborne. The first one that everyone remembers is CCA. It was developed back in the 30s. It too is a restricted use pesticide. It's been used since the 40s. Sometimes it's hard to believe that it's been around that long because most of the US market didn't really start using it until the 70s when we had the oil embargo. It's a great preservative for contact in fresh salt water immersion and other industrial uses. And prior to 2004, it had 80% of the residential market, but that was when the registrants pulled it from residential and maintained the industrial and agricultural uses. It has been restricted or banned in some countries, but where it is used, it's one of the dominant preservatives. And it's really used a lot, mostly in pines and those kind of products, poles, piles, agricultural posts, and timbers, because they seem to take it very well and it performs real well. ACZA. This one was developed as ACA in the 1920s, actually at the University of California, Berkeley, and was originally developed to be a live tree preservative. They were having a lot of problem with insect attack on their nut trees in the area because they grow a lot of almonds and various things out there, and they were trying to find a way to protect them. And what they found was after they went back and the nut trees had been cut down, the stumps were still good. So then they started looking at it as a wood preservative. It does a great job and actually covers more, is used in more applications in AWPA than any other preservative. It also can have borates added into the treating solution if you want to once again boost the preservative value, because it's used on Western species or difficult to treat species such as Douglas fir, and then also in hardwoods, and does a great job with both of those. It's also different from the other waterbornes in that this is the only waterborne where heat is used as part of the treating process. ACQ, the first of the residential preservatives to actually kind of get a lot of use. It was originally developed by Stella Jones. It is not unclassified. The conversion to the amine formula made it suitable for eastern species, whereas on the western formulation originally done, it used ammonia. They were in the early stages, it had some issues with corrosion. So that it, based on the quat that was used in it, so they would convert it to the carbo quat, and that alleviated most of those things. But unfortunately, it has now moved into a situation where it's no longer being used, or it's no longer being provided chemically. It may still be treating, but once the plants are out of it, it will be out of use due to the quats being used for other applications. Copperazole. This is the most popular of the residential preservatives now. Once again, it's also unclassified. You have four ways of looking at it. You have a type B, which has one azole. You have type C, which has two azoles. You have it either as dissolved, or you also can have it as micronized. So there are a lot of different variations of this preservative that can be available for treating processes. Metal-free products. These are typically used either for above ground applications on an exterior use for decking, PTI and EL2. SBX is boron, and it's used for interior use, protected from rainwater or flowing water. But these products all seem to do very well in protecting in the applications they've been chosen to be used for. These are some of the other preservatives that are out there. These are all copper-based waterbornes, copper HDO, KDS, and well, actually 2 forms of KDS. But we don't see a lot of these in the States at this point in time. So these will be ones to see how they further develop and how well they do in the marketplace. One of the things that was mentioned earlier are some of the additives that are used for protecting wood products. And we talk about moldicides, obviously they control mold. Colorants, pigments and dyes for color identification. Sometimes you use that for inventory control, as well as giving a nice even appearance to the wood for use. There's also penetration enhancers. Some of the newer products need a little aid in getting down deep into the wood. There are also things like defoamers, which in the treating plants can be very useful because some of these products have a tendency, as they're being stirred up or run through pumps, can create some foam. And so it becomes unsettled in the tank, and this allows it to do that, to settle down. Corrosion inhibitors. Once again, this is for protecting the treating plant. Some of these products are a little corrosive, and so if we do this, add these in there, it makes everything last longer. Pre-stains are once again going into the color things, but they're applied in cylinder prior to treatment. And then you come back and treat over it. Water repellents that are incorporated into the treatments themselves to help reduce swelling and shrinking. We have surface treatments. These can be used just for white lumber. Once again, to control mold, stains, and decay, and some fungi and insects. It can be used in things that are used just for framing, just to make sure that the wood stays, and also if it make the wood stay bright between the time it's produced at a sawmill and by the time the preservative is added to it. One other thing that's out there that's not really an additive, or the ET products that are added as a second step process on the outside, sort of like we have the pre-stains. This would be like a post thing, and it comes in clear and brown, and they're added mostly for utility poles to aid in the climbing of the waterborne poles, because it's not that they make them harder, but it's just that they don't have the lubrication effect of the oil bornes. And ET includes, it's an emulsified treatment, and it includes oil. Regulations, and you're going to hear more about this stuff later, but this just kind of gives you an idea of the end uses, what's restricted and what's a general use or unclassified. And that general use is most of the time the term you hear, but the technical term is unclassified. So you can see here the various products that fall into these categories. How do we determine the classification? Like I said, there'll be more stuff about this later, but this is just kind of a brief intro just to make sure you're kind of thinking in the right terms of what's a restricted use pesticide, what kind of labeling requirements are on there because of its classifications. And one of the things to remember is that RUPs are not available for use or purchased by the general public. If you remember, once upon a time, you used to be able to buy creosote over the counter and some of the things like that, but that's no longer possible. Certified applicators, which is why we're all here today. If you're applying or supervising the use of, in particular, restricted use pesticides, you must be certified or have someone on your site that is certified. And also, as sellers of these products, we have to have a registered pesticide applicator in the state of sale. I know, as I tell folks a lot of times, I said, don't bug me because I'm registered to kill pests in 8 states. So those are things to remember. You have to have training programs like the one we've got today to make sure you maintain your certification, and EPA oversees these programs, although each state has their variations of those, as most of you are aware. Your state may require you to take a class every year or accumulate a number of points over 3 to 5 years. So it's all about making sure that you know how to handle these products safely, and make sure that the end user also is protected when they buy these treated wood products. And so what is a pesticide? It's anything that protects against pests. And we're not, and pesticides are not just wood products. You're talking about household cleaners, insect repellents, weed killers, pool chemicals, even toothpaste. So there are so many things we use that are pesticides that a lot of times we don't even think about, and probably toothpaste is the best example. Most of them have, if you'll remember, have sodium fluoride. In my time, I've done remedial treatments of utility poles, and I put a lot of sodium fluoride on utility poles once upon a time because it kills decay fungi, which is what we're trying to do, stop tooth decay. It's all the same thing. It's usually always a matter of how you use it and making sure you do things properly and safely. Here are the different toxicity categories. Once again, this is just kind of making you start thinking in these terms. There'll be more discussions about this later. And here are the areas of toxicity exposure. You have acute, oral, dermal, and inhalation. You have eye irritation. You got skin irritations. You have dermal sensitization. So there's different things. So you have the danger, warning, and caution, and then none required. So always look on your label and make sure you know what you're dealing with and what you need to be aware of. And here's how they break it down as to the level of what kind of exposure causes problems for the individuals. So you have the category 1, which is obviously the worst. Category 2 gets a little better. Category 3, and then category 4. And you can look at the multipliers of exposure level of what kind of level of material can be there. So anyway, once again, this information is all on the label. So be aware of that and make sure you stay up on this. And that's why we do these training sessions. Stay on top of this stuff. Stay safe. Everybody wants everybody to go home at the end of the day. Here's an example of a restricted use pesticide label. Probably can't see it too well on the screen, but anyway, these are some of the things that are on there. That has the signal word. It tells you what PPE to wear, safety requirements, environmental hazards, the first aid, how to use it, how to store it and dispose of it. All this information is on the label. And this is an unclassified. One of the things that you may, I don't know if you can notice it, but right underneath the woman E name in the middle, it says for industrial use only. And what that refers to is the fact that this product is made for application in a manufacturing setting. Once again, it is not for over-the-counter use. So even though it is a unclassified product, it still is not meant for just general public use in a concentrate form. So, excuse me, how do we limit exposure to the environment and people, which is what we want to try to accomplish? We want to do the job, protect the wood, and protect the people and the environment that we're around it. We'll do that through engineering controls, safe handling procedures, containment, housekeeping, and PPE. All information you can find on your label. Engineering controls. If you'll remember a few years ago now, we've added the purge at the end of the treating process for waterbornes and oilbornes that are restricted use pesticides. You have to empty 2 cylinder volumes of air prior to fully opening the door. The final vacuum has to exceed the initial vacuum, and that's a multiplier of minutes and inches. So you may pull less inches at the end, but that means you have to pull it for a longer time to accomplish this. We did away with bolt doors. We all have quick opening doors. We have the subpart W requirements for the drip pad. There's a door pit requirement where the cylinders and the door pits, they gotta have grading to make sure nobody can step into solution. You gotta have sumps where you empty these things out. You have the door opening and cylinder mainlets. You gotta be wearing your PPE when you're up around the door doing work on it. And especially anytime you're working within 15 feet of the cylinder door while the door is open. And treated material. You now have to make sure you have mechanical bridges. They're not loaded by people. They have to be put in by lift or automatically raise and lower. So those are some of the things that have been done to help make sure people in the treating plant are protected. Today's automation in today's plant also helps with the protection of the people involved, because you got automatic valves. You can watch what's going on. If there's something that happens within the treating process, the system will shut itself down so that there's no opportunity for further exposure. Safe handling. This is, once again, this is information on the label. PPE. This is, once again, from the label itself. So you have all this information available to you. One of the things that we've had for years was the Lonza calendar, and then a few years ago we developed it as changed it to an EH&S calendar, so you can use this to help know when you need to do certain things in your plant. So if you don't have one in your plant, every plant should be getting one, but if you don't have one, please make sure you let us know so we can get one to you. One of the things we include with that is on the back page is a list of stickers for different things that you should be doing. And it's probably hard to see here, but you can use this to help you plan out your year of when you need to monitor this, when you need to check that, when this needs to be inspected. All these things from an environmental health and safety aspect. Once again, always trying to make sure we keep you guys safe in your activities in the plant. The other thing that's important is talking with your salespeople so that you can make sure that when the product is out there, that they're putting in the right product for the right use. All this goes back to AWPA, which we talked about. It has a lot of varied membership. It includes end users, producers, treaters, specifiers, academia, to make sure things are done right. It's based on a parliamentary procedure, and these are what it's based on. You have preservative committees, treatment committees, and special committees that make up the AWPA. There's all kinds of pre-testing done prior to a preservative being approved for being included in AWPA. Here's the use categories that was mentioned earlier, from everything from interior protected all the way through fire retardants. Those are all in AWPA. And that's kind of it from my perspective. So once again, if you have any questions, please make sure you let us know. Thank you.
Thanks, Tim. I don't see any questions popping up. So let's take a break, but we're not going to go till it says on the agenda. Why don't we start that now and come back at, let's say 9:50 Eastern Daylight Time for our next presenter. Is that okay, Belinda and Sarah?
Thank you, Grady. Yes, that's perfect. And everyone just leave your computer on as it is. Don't turn it off or anything. And if you come back, we'll take up right where we left off. Thank you.
Okay, 9:50. Thank you, everyone. Well, good morning again, everyone. It's 9:50. Welcome back to the 2020 Lonza Plant Operators Seminar. Our next speaker is John Wong, who will be speaking to us about wood preservative treating science. John is a senior research scientist with Lonza, where he puts his expertise to use designing, scheduling, and executing new products or processes for engineered wood and other products. He collaborates with industry partners to commercialize products invented in the lab or develop new commercial products. He independently designed, planned, and conducted research to synthesize or formulate adhesives for making wood composites, and performed evaluation in accordance with ASTM and other test methods. John has his MS degree in wood science from Oregon State University and his ME in applied chemistry and BE in polymer materials from Daelan University of Technology. He has several published journal articles and holds 3 patents. John, you're on.
Thank you. Oh. Oh. Okay. Good morning, everyone. Today, I'm going to talk about wood structure and the liquid flow in softwoods. We know wood is a porous material, but it's not very permeable. So why? So hopefully this presentation can help you understand this region. So let's start. Wood is from tree. So I will talk about how tree grows first. Then we will look at the wood structure to learn about the types of wood cell and the green direction, something like that. After that, I will talk about how liquid flow in wood. At last, I will give you some suggestions like how to improve liquid flow in wood. So basically, tree is a conical shape. It's bigger at the bottom and smaller on the top. The old wood formed in the center of the tree. The new wood is close to the bark. The wood formed in the first 10 to 15 years it's called juvenile wood. Juvenile wood generally is regarded as a low quality wood because it's high anatomical variability, low density, and higher longitudinal shrinkage compared to mature wood. So mature wood is more stable and stronger than the juvenile wood. So if we cut a tree, look at from the one end of the tree, this is what we will see. The outside layer is bark, is to protect the tree. The layer under the bark is called phloem. Phloem is a layer to transport the sugar and the nutrition from leaves to the roots of the tree. The layer next to phloem is called cambium. Cambium is an active layer in wood. Its role is to produce new wood cells. It produces wood cell to outside to form phloem, to inside to form xylem. The light color part is sapwood. Sapwood is the new wood part in the tree, and its role, sapwood is like the water pipeline in tree. It conducts or transport water from root to the top of the tree. As the new rings of sapwood form, the inner cells will die to form heartwood. You see, heartwood has a darker color than sapwood. That's because of the extractives in heartwood. Heartwood the wood cell in hardwood is dead, but its strength is still there. It won't decay as long as the outer layer is good, in a good shape. Then if we take a picture for part of the growth ring, this is what we can see. We can see early wood and late wood. Early wood actually is formed at the beginning of the growing season. Sometimes people call it a spring wood too. We see the early wood has a bigger wood cell and a thin cell wall. Compared to earlier wood, late wood actually is formed later in the growing season. It's also called summer wood. Its cell wall is smaller, and the thickness of the cell wall is thicker than earlier wood. So based on the size of the wood cell, we can see that in the living tree, it should be easier for water to go through the early wood than late wood in the green conditions. The properties of wood differ in different directions. We need to know 3 directions of wood: longitudinal, radial, and tangential. Longitudinal direction actually is the direction of the trunk. The radial section actually is the surface that from the center of the tree to the bark. The tangential section is tangential to the growth ring. We should keep these 3 directions in mind because we will talk about in the following slides. If we put a small piece of wood under microscope, this is what we can see. Based on these 3 directions, we can see maybe this is a part we took from here. This longitudinal, radial direction, and tangential direction. This is the part. So in this picture, basically based on the direction of the wood cells, we can say they are vertical wood cells and horizontal wood cells. In the vertical direction, we talk about the early wood and the late wood. Based on the size of the wood cell and the thickness of the cell, we can tell this part is the early wood, this part is the late wood. This is the rhizome canal. This on the radial direction, we can see some wood cell like a ray parenchyma or ray trichis. We will talk about these wood cells in the next slide. In the longitudinal direction, there are 3 types of wood cell: tricky, parenchyma, and epithelial. Tricky is the most important wood cell in wood, and in softwood, trichies accounts for about 90 or 95% of the volume of softwood. And the tricky is a long, hollow, and a narrow tube. Its length about 3 to 4 millimeter. And the parenchyma and the epithelial are much shorter than tricky. In the ray direction, actually it's also called the radial direction, there are also tricky parenchyma and epithelial cells. But in the ray direction, the tricky is much shorter than the longitudinal direction. Epithelial cells are shortest compared to these 2. And the cells around the rhizome canal actually are from the epithelial cells. Then we'll talk about almost the most important part in this presentation piece. If we say the longitudinal trichies are like the water pipeline, in wood, pieces are the valves connecting this water pipeline. So the impregnation is highly dependent on these valves. In wood, basically there are two types of pit: simple pit and bordered pit. A belongs to simple pit, and B and C are bordered pits. C actually is called half bordered pit. All pits have two components: cavity and pit membrane. In simple pit, the cavity is almost constant in width, but in the bordered pits, the cavity narrows towards the cell. In bordered pits, the center part of the pit membrane is much thicker than the area around it. But in the half-bordered pit, the pit membrane is as same as the simple pit. You can see the simple pit on reed parenchyma. On tree keys, you will see the bordered pits. For the half-bordered pits, you can see where the vertical tree keys meets the reed parenchyma. That's where the vertical cells meet with the horizontal cells. So vertical cells has the piece on vertical cells has borders, but there's no borders on the reed parenchyma. So when they meet each other, they only have half border. So this is this picture, especially for the bordered piece. We said that the center part is pretty thick. It's called torus. And the area around the torus is called margo. We see these are microfibril structure. It's not as dense as torus. So when water flow through this pit, it's easier for water to go through margo than torus. So after we talk about the wood structure, the next we will talk about the flow mechanisms in wood. In wood, basically there are three mechanisms: diffusion, capillary action, bulk flow. With non-pressure treatment, diffusion, capillary action are the dominant mechanism. With pressure treatment, bulk flow is the dominant mechanism. Then we will talk about one by one next. Diffusion actually is a molecular process that happens due to the concentration gradient. In this picture, you see at the beginning, all molecules stay in the one corner of the solution. Due to diffusion, the molecules will spread out to the whole solution. That's called diffusion. Capillary action is the penetration of the liquid into the capillary structure. Then it will flow through the structure. When liquid flow into the capillary structure, actually there are two forces. One is called cohesion, the other is adhesion. Cohesion here actually is the force inside of the water that keeps the water molecule together. Adhesion is a force between the wall of this vessel to the water molecule. We know there's a lot of cellulose in wood. Cellulose have hydroxy groups. These hydroxy groups can form hydrogen bonding with water molecule. So when the adhesion is stronger than cohesion, the molecules next to the wall will be pulled up. So that's why the solution can move up in the capillary structure. So it's found that with the smaller diameter of this vessel, the liquid in this capillary structure can move higher. For the bulk flow, it's easy to understand is related to the length of the structure and the pressure difference. The higher pressure difference, the shorter the length of the structure, the bulk flow will be more significant. When we talk about the liquid flow in wood, we need to understand the two concepts, permeability and the treatability. Sometimes these two concepts are used interchangeably, but they are still different. Permeability actually is to measure how easy a liquid can flow through wood. But the treatability is that if the material can penetrate in wood and stay in wood. How liquid flow in wood? In the longitudinal direction, liquid just basically flows through the longitudinal trachea and the resin canal. Although resin canal is much bigger than trachea, sometimes the resin canal will be filled with resin or extractives, so water cannot flow through the resin canal. So trachea is the most important for the liquid flow in the longitudinal direction. And the border piece connecting two longitudinal tracheas, the water from one cell lumen will flow through the one bordered pit into another wood cell. In the radial direction, the water basically flows through the ray parenchyma and the resin canal. There are not much piece on the radial direction, so the effect of radial pitting on the liquid flow can be ignored here. Basically, the liquid flow through the resin canal and the parenchyma in the radial direction. In the tangential direction, liquid flow through the pittings. They can flow through the tangential pitting or the cross-feed pitting. Cross-feed pitting is a pitting where the vertical cells meet with the horizontal cells. This is the early wood. This is from the late wood. Again, we can see early wood has a thinner cell wall and a much bigger the size of the cell than the late wood. So at the beginning of the presentation, we said wood is porous, but it's not very permeable. That's because of the little intercommunication in wood cells. This poor intercommunication actually is because of the peat aspiration. Peat aspiration can be caused by pressure difference in the wood cells. Peat actually is like a valve connecting these two wood cells. When the pressure in these two wood cells are different, the pressure will push this peat towards to the side with lower pressure. So the peat membrane will be shaped to seal this aperture. So when the aperture is sealed, the water cannot flow through the valve. That's why the intercommunication of the cell wall, the wood cell, become poor after the peat aspiration. So we said pressure difference is one of the reasons to cause the peat aspiration. Then we can talk about in details. So the factors controlling aspiration, actually there are three factors. One factor is from the surface tension force of the liquid flowing through the peat. It was found that the higher the tension force of the liquid, the more peat will become aspirated. And then it also depends on the stiffness or the thickness of the peat membrane. We know the torus is part of the peat membrane. If the peat membrane is thicker or stiffer, so it makes sense it's harder to move or change the shape of the membrane to move it to the aperture, to seal the aperture. So the stiffer the membrane, the harder to aspirate the peat. Then it also depends on the adhesion of the torus to the border. Okay, let's see how peat aspiration can affect the liquid flow in wood. In sapwood and hardwood, it's easier to understand that the flow is much easier in sapwood than hardwood. That's because in hardwood, some peats are closed because of the peat aspiration, and also there are more extractives in hardwood. It's not easy for liquid to flow in hardwood. And flow in late wood is better than early wood. Actually, this is for the wood after drying. In green condition, it should be that it's easier to flow, for liquid flow in early wood than late wood, because early wood has a larger and more piece than late wood. But after the wood is dried, some piece in early wood will be closed. But as we said, late wood has a smaller wood cell, and the thicker peat membrane. The thicker peat membrane that means it needs higher force to close the piece. So that's why after wood is dry, the flow in late wood is better than early wood. And then drying, if you dry wood too much, piece will become aspirated. That will significantly reduce the liquid flow in wood. Then some liquid properties can also affect the liquid flow, like the viscosity and the surface tension. We said that the higher surface tension of the liquid, the more piece will be closed. And also we want to avoid some contaminants in the liquid, like particles, extractives, also some dissolved gases. So how to improve the liquid flow in wood? First thing is that let's choose the wood that can be easily treated. So this picture showed classification of hardwood treated with aqueous preservatives. It's divided into 4 classes: easier to treat, moderately easy to treat, difficult to treat, extremely difficult to treat. So if you want to learn the details about this classification, you can check this literature. It's a very nice review for this information. And then you want to dry wood to a certain moisture content. If the wood is too wet, that means there are fewer voids in wood. So it's hard for preservative to go into the wood, and you also need a higher pressure to overcome the air bubbles in wood. And you may want to filter the solution periodically to remove some particles. And you also want to use up the old solutions with full cell treatments and try alterations in the treating schedule. The last 2 methods, the purpose of the last 2 methods are to provide the fresh solution for treating wood. Okay, basically that's all about this presentation. Thank you.
Thank you, John. very much. If you have any questions, please send them, type them in the chat section and we'll get to it. We do have a question from Tim's presentation, and that question is, Tim said that restricted use pesticide applicators must have a licensed pesticide applicator in all states where they sell them. Does that mean that they need an applicator for the destination state or just the state where the product is produced? Well, the second part of that is correct. Lonza, as the restricted use pesticide manufacturer, has to have an applicator's license in each state that we sell a pesticide such as a CCA, pesticide applicator's license in each state. The treater only needs a pesticide applicator's license in the state they treat. So that answers that. Thank you for that question. The next speaker is John McMillan. And John will be doing the second half of the wood preservative treating science section, talking about pesticide application equipment and treating cycles. And John is a technical service rep with Lonza, has been in the wood preservation industry for 43 years. He doesn't look that old, does he? He supports customers with quality control, treating processes, and troubleshooting as issues arise. John identifies trends or problems in customers' wood solution analysis. Before joining Lonza 10 years ago, John worked at Georgia Pacific, Fibertech Wood, and Cox Industries. He attended Sumter Technical College studying civil engineering. John, you're up.
Good morning. To follow up on John's presentation just before me, when he talks about pit aspiration, the two main issues that you're going to see is coming from sawmills where they don't monitor a wet bulb, and the pressures outside the wood with very dry heat, and the moist heat inside the wood will cause the cells to aspirate, and it's very hard to penetrate. The other way you'll see that problem is if you treat extremely modified cycles, and you don't use a slow pressure release, you can have the pit aspiration exactly the opposite way, and you get the delayed bleeding. So in saying that, let's get right into this. Make sure I can do this. We're going to talk about the steps of a treating cycle, what happens during those steps, 4 different treating cycles, the differences in them, net versus gross injection, charge reports, do you know the numbers, and some simple calculations that can help you, mainly for helping treat all your wood, but mainly when you're having to treat something out of the ordinary. So people that have a treat right system, I'm sure you've seen this graph. Pretty much all processes are an initial vacuum. You fill under that vacuum. You have raised pressure. You maintain that pressure. Then you have a release pressure step. You empty the cylinder, have a final vacuum, and then drain. So when you begin a cycle, I have up here full cell cycles, but this is basically modified or full cell. You're calculating the tally, you're entering it, you note your desired retention, above ground, ground contact. For CCA producers, it's quite a variety of 6.0 marine treatment, 6.0 for poles, 2.5 pound for marine, different retentions for different areas of the world. You consider an expected solution uptake. If you're a manual treater, you can calculate this out. We'll talk about that later. You determine the necessary solution, concentration you need to treat, and you record your tank readings, which is very important for understanding what's going on inside the cylinder. So when you pull the initial vacuum, you achieve and maintain that desired vacuum for a specific time. That could be immediately when you reach that vacuum, or it could be whatever time interval you have set up in presets or of known treating cycles that you know that work. You maintain that vacuum during fill. The reason that's so important is if you're treating, let's say full cell, 25 inches of initial, and I'm filling the cylinder, and by the time I finish filling the cylinder, I'm down to about 12 inches, which is a modified cycle. Then what ends up happening is the top layer of the wood is treated modified, the bottom layer is treated full cell, so there's two different retentions. If you're treating full cell, more than likely the top layer of the wood is going to be below retention and fail for that reason. You want to record your tank readings and equalize after you fill. In the treat right system, they have atmospheric absorption. I mentioned the pit aspiration earlier because if you're buying from hard to treat mills, one of the things that seems effective in atmospheric absorption, you can actually let it sit there for a few minutes. 3 to 5 seems to work for most people. And the way I kind of found this out is people in Florida would say they would leave the wood out in the rain. And the only thing I can figure is happening is it's rehydrating the wood. So the cells unaspirate enough to where you can get penetration. So if you're having problems penetrating wood, just contact your rep, contact myself, and we can help you with that. We've seen to have some success doing this. You pressure cycle as you press to achieve penetration. Simple enough, but basically when you think about the entire cycles, initial vacuum and final vacuum are there. You're controlling how much air you're leaving in the wood, which has to do with how much kickback you get in final vacuum. Pressure is for penetration. It's not separate, but it's just there to make sure you get penetration. And when you're treating large poles, CCA treatments, things of that nature, the press cycles can be quite long. So when you're emptying the cylinder after treating, sometimes people have a four-way valve that will reverse, and instead of pulling a vacuum, pulling air out of the system to ambient air, it'll pull from ambient air and put air pressure in the system to blow the solution out with air pressure. Or some systems have a transfer pump that'll do the same thing, just not quite as fast. So when you have the cylinder empty, you apply the final vacuum. And basically under final vacuum, what ends up happening is whatever air you have inside the wood expands. The best way I know to explain that, if anybody remembers science class, did you ever make cold water boil? And basically that's where you pull a vacuum on the outside of a beaker of water and you're displacing the pressure that's in the water versus the air pressure, and the air inside the water will expand like a balloon. Well, the same thing happens in wood and pushes the excess solution out. So when you're done with final vacuum and treat right systems, there's a strip pump, or it might be a pressure pump that uses a strip pump. And by the time you get to the end of vacuum, you're ready to open the door. It's stripped all the excess liquid out. If not, this is a process where you will go through and empty the cylinder, or even after vacuum, it might get residual out. At this time, you'll get your final tank reading, and this reading, along with the beginning, will help understand your net injection. So 4 different types of treating cycles that I see in the world is a full cell. It begins with an initial vacuum of 22 inches of vacuum or more. Modified cycles, that begins with an initial vacuum of less than 22 inches of vacuum. Lowry begins at atmospheric pressure. There is no vacuum at all. You just start filling the cylinder. are roofing, believe it or not, there are people that treat with this. Normally it says Old-Bournes and creosote, but I've seen some waterbornes done this way. And you have to use a transfer pump to fill the cylinder because you're using a large air compressor to create air pressure. Usually it's about 8 or 10 psi. And this helps with kickback in final vacuum. We'll discuss that in just a little bit. This is usually full cell cycles 22 inches or higher, usually a high solution pickup. Modified, less than 22 inches, less than 3 gallons a cube is normally your net. But the difference in the 4 cycles, the main difference is the amount of air you're allowing in the wood to remain at the beginning of the process. And what this does is this allows you quite a bit of kickback the more air you leave in the wood. And you can see at the bottom of each one of these rectangles shows the different net gallons a cube you can achieve. If you dry wood after treatment, obviously you want to go modified, possibly is Lowry an option, is roofing an option. One of the things to consider when you're talking about modified cycles, CCA in the deep south in the summertime, the more wood sugars you get in kickback will cause a sludge. The same chemical reaction that happens in your wood will happen in your solution from the wood sugars and extractives you get back in your solution. So we talk about gross injection. What is that? That's basically the difference between the beginning of pressure and ending pressure. And why is that number important? You can tell from the size of this, this is a small cylinder, but it works in any size cylinder is what I'm talking about. Is where we need to compare that to net injection. What is net injection? That's the difference between the beginning and end of the cycle. If you notice the 510 minus the 430 tells you how much kickback you're getting. If you're treating modified roofing or Lowry cycles, this number is very significant. And it can help you control not only weights for freight and different things like that, but it can also it can help with not only a lighter product if you're drying after treatment, things like that. So going into charge reports, whether you're doing this manually, whether it's treat right, do you know what the numbers are? If you're looking at when you're looking at this, when you look at the top section and you see the different steps of the process, you'll notice an SP and an ACT. The SP stands for set point, the ACT is actual. So for this particular cylinder, their maximum time at 21 inches of vacuum, they want to stay in for 5 minutes. They were at 21.18 and it took 14 minutes. Basically what that means is it took about 9 minutes to get to the set point of 21, then it stayed at 5. As you go down and look at all those numbers, let's say pressure, it shows a injection rate of 3.5 set point, 16 minimum, 17 maximum at 150. And you can see they basically at 17 minutes, the maximum time, they met 3.46, they got to 146.39. The same with final vacuum. It's good to know those numbers and know what is exactly happening in your cylinder. These numbers are significant because this one we're talking about gross versus net. At the end of vacuum fill, you're looking at 7.2. Keep that number in mind. I'll talk about it later. At the end of pressure, we're at 3.2. All these numbers, if you're treating the same thing over and over, these numbers will look very similar from charge to charge, depending on the mills you're treating. It's good to know what these numbers are looking like because sometimes if you see an anomaly, you sometimes can find a problem during the charge before and maybe stop it, fix whatever's happening, and so you don't have to end up retreating a charge or something like that. So charge data. One of the things that I will always like people to understand, when you look at calculated chemical used in pounds, and this is CCA, it doesn't matter what preservative, copper-based products, whatever, it's basically taking the total gallons times the weight per gallon of the preservative, 8.4 for copper-based products, 8.5 for CCA products, and yet gives you pounds of solution. Then you multiply times whatever your solution percent is, that gives you calculated pounds used. That is a good number sometimes. You know, treat right, the whole process is all, it's good to know these numbers so you can double check, make sure everything's calculating correctly. Sometimes you can find a problem with a DP cell or anything like that that might be acting up if you notice an anomaly with these numbers. As I said, CCA weighs approximately 8.5. Copper-based products are about 8.4. And the reason I show you that little calculation, it's nice to know how you come up with gallons of what your net gallons of cube are, what your gross gallons of cube are, and how to calculate that into pounds. The reason the pounds are significant is with this simple calculation, you can determine what your solution strength needs to be. For instance, if I wanted to know, if I was obviously it'd be 0.06, but if I reversed and I said 0.05 divided by 25 pounds, that would give me 0.2%. So let's say I'm treating something out of the ordinary. If I know what my net gallons of cube are normally, convert that into pounds of solution, then I can take whatever retention I'm treating, regardless of preservative, and I can divide the retention by the pounds of solution, and that'll give me a starting point for what my solution percent needs to be. For instance, if you're used to treating, let's say 6.0 material poles all the time, and all of a sudden somebody wants you to treat 8.0, same thing. Instead of 0.60, you just put in 0.80, and it gives you a starting point for understanding that. Gallons per cube times total cubic feet of wood in the cellar is the total preservative solution required. So in other words, if I got 692 cubic feet, I know I need to treat, normally charge is about 2.98 gallons per cube. Then I know if I'm treating out of my work tank from the time I start pressure, I'm going to drop 2,062 gallons. The reason this is significant is, example, remember when I said to remember to the 7.2 and 3.2? It's also nice to know what is your gross gallons per cubic foot when you treat, because in this situation, they're treating the 3.46 gallons per cube gross. Their net is 2.98. That difference is what they should normally see with every charge they treat if this is a normal process. Whatever your processes are, if you're treating a charge and you know these numbers, and all of a sudden you're seeing a number that's just way out of the norm for what you're seeing, sometimes you can find the problem without even opening the cylinder door. Maybe you have to retreat it, maybe go back into pressure, maybe the wood was wet. You know, sometimes it's a red flag to help you understand what happened while you treat it. So when you're talking about quality control, you know, obviously the more assay, the more information you have from charge reports, the more data you have, the more information you can understand what it takes to treat the wood you're buying. Wood being the biggest anomaly out there. For you guys that live up north versus us in the south, versus out west, the wood is the biggest difference. We can take a plant from the south, put it up north, vice versa, and it's just going to treat different based on your wood sources. For those of you who have XRF machines, regardless of the brand, you need in-house standard samples that are known samples so you can run them on them every day, so you can make sure that that's running correctly, analyzing correctly for solution and wood to make sure that all the wood you're treating is meeting AWPA requirements and our requirements at Lonza. Third-party inspection, to understand the difference between plant analysis, Lonza analysis, third-party is a good number to know, because that way you can understand from charges being treated whether they're going to pass third-party if you know that information. That's pretty much all I got. Thank you for your time. Hope everybody's getting a little bit out of this. And that's it, Grady.
Thank you, John. We appreciate it. If anybody has any questions for John, please send them in via the chat section.
Grady, there's one question.
Okay.
It says the calculation forms that John is talking about, are samples available, and is this info included in the Lonza manual?
No, it's one of those things. If somebody wants to shoot me an email, I can always send them this presentation for info. Be more than glad to do that.
Any other questions for John? Thank you. I seem to be getting a voicemail on my message machine. Sorry about that. My wife's not here when I need her. Anyway, our next speaker is Kelly Spence, and Kelly will be chatting with us about elements of a successful in-plant QC program. And little introduction to Kelly, if you don't know her, has served as manager of the treated wood division at Timber Products since 2017. Prior to that, she has 9 years of experience as an internal wood treating technical resource to treated wood manufacturing facilities focused on quality control, process control, training, and process data analysis. She also has 8 years of experience working in environmental compliance and consulting, with focus on regulatory compliance and program management in the wood products and treated wood industry. She received her BS in environmental science from Lake Superior State University and her ME in environmental engineering from Vanderbilt. Kelly is a member of AWPA, currently serving as secretary of the T2 Lumber and Timber Committee. She is a member of the Treated Wood Council, currently serving as chair of the Government Affairs Committee. In addition, Kelly is a member of the WWPI. Quite a resume, Kelly. Welcome.
Yeah, I've been around. How's everyone doing? You can hear me, I hope. I know I'm standing in between you and lunch, so we're gonna cruise through this information, and please don't hesitate to type in questions if you have any. So we're gonna talk in general about quality control program, and specifically we'll talk about sampling, analysis, and inspection and conformance monitoring. Make sure, there we go. So sampling, I mean, that's a key part of your plant's quality control program. And, you know, we'll talk a little bit about why do we do it, what standards are applicable, processes, you know, for sampling, as well as the specific equipment that's used. So why do we sample? We do it to demonstrate the product meets the specifications. So most of the time you've got a requirement with, per the standard that requires you to hit certain penetration and retention requirements. The other big part is, you sample so that you can control the process. It's very important that you meet the standards, but I'm sure all of your managers and your internal requirements say, hey, we don't want you to overtreat either. So you want to try to hit that sweet spot, and sampling helps you determine that you're not undertreating, but you're not overtreating either. And ultimately we do it because we're required to do it, right? The AWPA is really the book that determines the standards that are applicable to our quality control process. So, here's the list of the various standards. I won't read through all of them. We've got different standards for different commodities, different requirements, and different quality control processes depending on whether you're doing residential type treatments or industrial type treatments. There are some slight differences there. So let's just talk a little bit about, sampling equipment. We've got some specialized tools that we use in our jobs to, collect core samples. We have the special core trays that give us the, help guide us to the proper depths of penetration, the proper assay zones. We use, special core drill bits to, pull the proper sized core out of our wood. We use, special drills in order to do that. We've got little plugs, that we plug the holes with. And these are all tools that have been developed to help you achieve what the standard requires. Big part of sampling is, making sure that you are sampling in accordance with what the standard says. And a big part of that is using a sampling pattern to eliminate bias in your sampling. So you want to make sure that you are getting a good representative sample from your charge. And using an established pattern helps you get that representative sample. So, drill one, skip one, drill one, skip one. You don't want to be picking and choosing boards based on what you think is going to give you the results you want. The first part of our quality control process is evaluating the penetration. So as you guys all know, there's two steps to quality control. It's penetration and it's retention. So step one is checking the penetration. Each standard, like I mentioned, has different requirements as far as depth of penetration. There's required minimums. You've got the required number of sample or of cores that you have to pass. For sawn lumber in southern pine, which is probably something you guys are familiar with, you've got to have 2.5 inches of penetration or half the width of the board, and you've got to have 85% of that sapwood treated. So first we're going to determine where is sapwood and where is heartwood in those cores, and you use a heartwood penetration indicator to do that. And then you determine the penetration, and depending on what preservative you use, there are different penetration indicators. Rubianic acid is a common one that's used for copper-based wood preservatives like MCAC or CAC or CCA. So once you know you've passed the penetration part, then you can go on to step 2, which is the retention part of the quality control test. And again, there's a specific assay zone that you have to test. And that's dependent on your species, dependent on what commodity you're testing. So you want to make sure you know the rules. And you also want to know the rules on if you're supposed to include heartwood in the assay zone or not. Southern pine, for instance, you would not include heartwood in the assay zone. If you had a core that had some heartwood in the assay zone, you would replace it with a different core that has all sapwood. For Western species, you do include heartwood in the assay zone, so you got to know the rules. And you'll use your tray, these specialized core trays, have the cut lines in the, various locations. This one, it looks like it's got an assay zone cut line at 0.6 of an inch, which is what we use for 2-inch southern pine material, like a 2x4 or a 2x6. And it looks like it's got another cut line at 1 inch, which is what we would use for southern pine timbers, like 4x4s, 4x6, 6x6. And then now that you've collected your assays, your assay zones from your cores, you are next going to go to retention analysis. And I'm going to focus here just on talking about XRF analysis, which is your X-ray fluorescence, your Oxfords, your Asomas, because I think that's going to be kind of the most applicable to everybody.
Excuse me, Kelly,
Yeah.
your voice keeps going in and out. So I don't know. I think some of the audience may be missing some of the information you're providing.
Oh, thank you. I had no idea. So let me see if I can get a little closer to the microphone here. Just pipe in and let me know if it's still happening. So let's talk about sample preparation. So, we've got to go from these little, assay zone cores to dust, which is what gets analyzed in your XRF. And sample preparation is just as important as, the actual sample analysis. If you don't prepare the sample correctly, that can have a big influence on how accurate and how representative of what's actually in the wood your retention analysis is. So here's some examples of the various XRF devices, instruments that are out there and commonly used. This Spectro Asoma model, that's one of the older, older workhorse models. There haven't been any new ones that have come out since the Phoenix 2. Company called Z-Tex does, they'll do maintenance on those, service. Oxford is another commonly found instrument in a lot of the treating plants. Oxford actually exited the XRF market and transferred that technology over to a company called Hitachi. So Hitachi is a little newer to the wood preserving industry, and they've got a benchtop model that a lot of folks use. And then there's another company called Rigaku, which they also have a benchtop XRF model. All of these work very similar, similar operation, similar size, similar, level of accuracy. So XRF calibration and verification. So in order to analyze unknown samples in your XRF, you have to establish a calibration with known standards. So you'll build a mode in your XRF using known standards, and that is what your unknown standards get compared to. So these standards with known values are typically created by your chemical supplier. So, you know, Lonza would provide that to you. AWPA historically had created CCA and Penta samples, which I think are now have been used up. AWPA is currently working on coming out with some copper standards. And along with this calibration, you know, so you set that up once, and after that, I know John mentioned this too, you want to check daily that your calibration is holding strong. Calibrations can drift naturally over time, and you want to ensure that you're always reading within an acceptable range. So every day you're going to take a you know, sample that's got a known value, and you're going to put it in, you know, in your XRF and run it and check to make sure it's within plus or minus 5%, which is what the standard says is the acceptable value. If you're outside of that level, then you're going to want to start investigating and try to figure out what could be causing that difference. Inspections. This is kind of out of order, so sorry if I seem like I'm kind of jumping around here. We're missing some slides, and I'm hoping will still come up. So we'll talk about inspections and conformance monitoring. Guess we'll go back here. I'm just gonna, I know it's really small and hard to see, but I don't want to skip talking about the sample preparation part of things. So as we talked about, you're going from, you know, your little bits of core that you cut off the assay zone, and we need to get ourselves to sawdust, which can be analyzed in the XRF. And part of that process, you first are going to be drying your sample. So you're going to dry these little cores. The goal is to get your sample 0% moisture content, but to do it in a way that doesn't damage the sample in the process. So the gold standard for drying is really to use a laboratory forced air convection oven. That's going to allow you to have a very constant, consistent temperature, and it's going to let you very reliably dry these samples without burning them. So microwaves, I know a lot of folks, some folks still use microwaves, and those can be a little trickier to get consistent drying. You know, sometimes you might not get it all the way dry, other times it might be too hot and you could scorch your sample. So either one of those options is not great because it doesn't give you a very accurate result. So definitely an oven is the best, most consistent way of drying. And so you're going to dry your cores. If you're drying a, you know, MCAC or CAC or CCA, any of those copper based, like we've been talking about, you're going to dry those at about 103 degrees Celsius, and that's going to, you know, prevent you from burning or scorching anything, but it's going to get you down to that 0% moisture content that we want. So you dry those cores, and then you're going to grind them. And again, consistency, you know, we want to have a consistent grind size. You know, you want to have all those particles to be pretty much the same size. You want sample to sample to be very similar size. The gold standard in drying is a Wiley mill, and that's that blue guy kind of down in the bottom of that section. Those Wiley mills use a mesh screen, and that mesh size is defined in the standard, and what that lets you do is to collect only the portion of the standard that, or of the sample that got ground down to the right size that could pass through that sieve, pass through that mesh. So that again gives you that very consistent result. You know, there's a couple other grinders that folks will use. There's a flour mill and coffee grinders. You know, those, the issues there are just that consistency, you know, concern is trying to get that same particle size from sample to sample and within your one sample. I also know that those two types of grinders aren't quite as durable as those Wiley mills. I think the Wiley mills that we use in our lab, I think are probably a good 20 plus years old. Those things last forever. And then, so now that you've ground your sample down, you're going to dry that dust for a little while longer. And then that's going to get you down to that 0% moisture content, you know, prior to analysis. Couple other kind of miscellaneous tools that are useful in your sample prep are, you know, these aluminum sample pans. You always want to make sure you're using clean pans. You don't want to have any cross-contamination between samples. If you're using an Asoma, a lot of times those samples need to be pressed. So you would use a torque wrench or a press with a torque wrench. You want to make sure you're pressing it to the prescribed amount. I think it's typically 250 inch-pounds. And again, that's part of that whole consistency concept. You want to make sure that, you know, every time you're pressing the sample to the same amount, you want to make sure you're pressing it to the same amount that your calibration standards were pressed to. You know, driving that consistency from sample to sample. And then the other thing that you want to make sure you have is a NIST traceable thermometer. So this is just a you know, digital. This example here is a digital thermometer. You know, kind of like that you would use with your barbecue grill at home, where it's got a probe on a string that sticks in the oven, and then the readout is magnetic and you can stick it on the outside of the oven. And you want to rely on this thermometer, not the readout on your oven, because that readout on the oven isn't necessarily perfect. I know, you know, when, you know, think about your oven at home. You know, if you set your oven to 400 degrees, it might not be exactly 400 degrees. You know, use this thermometer to make sure that you're at the right temperature. All right, we talked about these guys, we talked about that. So we'll bounce back over here and get into inspections and conformance monitoring. So, you know, we've got in the wood treating industry, we've got kind of a 3-tier system set where you're doing your internal plant quality control on every charge. And then we've got on top of that a third-party inspection agency that will come in and check a percentage of your production. You're going to want to use an accredited third-party inspection agency. You know, we've got ALSC is, you know, the American Lumber Standard Committee. They are an accreditation body. IAS, which is the International Accreditation System. They are also an accreditation body, and both of these, IAS is the accreditor for the ICCES program. So a lot of agencies will be covered by both of these accreditations. You want to make sure you've got, you know, it's third party, it's independent. So, you know, this is an agency that, you know, doesn't have a vested interest in your treating program. You they're going to look at the ALSC program and ESR program material. Typically, they're going to offer laboratory services. So, they'll come in and collect samples, and then they'll analyze those samples in their own lab. And these agencies will also, in addition to doing these, kind of routine program inspections where they're coming in every month, they're also set up to be able to do independent or lot inspections. You guys may, have projects here and there where you need to have a third-party agency sample a specific lot of material and, provide you with a certificate or hammer brand that material. That's not uncommon for government type jobs where you need to have that, that specific material looked at. So the AWPA a few years ago established a standard for how a third-party agency evaluates those inspection samples they collect. So it's a set, very prescribed program to say, are you in good standing or are you on your way to, being in trouble? The program uses kind of a statistical process to evaluate the retention information and the penetration information. So for retention, it calculates a lower confidence limit. And this is of the last 20 charges sampled by the agency. So it kind of goes back in time and includes, however many inspections previous to get that 20 sample set. It's divvied up by a production category. So you may have a plant that's got multiple production categories. A production category is a combo of a preservative, a retention, and a species. So MCAC 0.15 Southern Yellow Pine. So that's one production category, that's one bucket. So you would be looking at the last 20 charges of that bucket. If you treated MCAC 0.06 Southern Pine, that would be a different bucket. And those two would get evaluated separately. On the penetration side, you calculate an average percent core conformance, which is basically just, the total conforming cores divided by the total cores. So if you had, 16 conforming, passing cores out of 20 total cores, you've got an 80% core conformance on that one charge. Again, for penetration, you're looking back over the most recent 20 samples, and you're doing it on a production category basis. So again, looking at those separate buckets. And you take those two calculations for each bucket, the retention LCL and the penetration APCC, and they get considered together to determine your inspection status, your M22 inspection status. And if you're kind of calculating above the line, so if your LCL and your APCC are above the line, then you're in routine status. That keeps you on, monthly visits. Nothing special has to be done. If you fall below the line, then that's going to bring you into an increased inspection status. If it continues, you would then go down into a warning status. And if you continue down that path, then that can lead you to a disqualification status. Once you get into those, the red, the yellow red categories, those are triggering more frequent inspections. So the agency, if you go into increased status, as it sounds, the agency would come in there on an increased frequency. They would, collect additional samples. Hopefully you've had a chance to make corrections and troubleshoot what the issue might have been, and get yourself back to routine status. But this is a very prescribed program that lets all plants be evaluated the same way, and gives a very set program for the agency to follow, and leads to plants having a very clear way of understanding where they're at with the agency, and what needs to be done to get back to routine status. Here's kind of a close-up view. At TP, we present this information to you in a graphical format. That's not required, but this is how we send out our reports. So this is an example of the LCL, which is again the retention evaluation. You'll see dates across the bottom, so those are the inspection dates. All the little blue dots are individual sample results, and you see the little red triangles are the calculated LCL. So you can see there's one triangle for each inspection, and then we kind of connect them with a green line just so you can see the trend over time. The red line is the minimum retention. So it's very easy to take a look at the graph and say, okay, are we, is the LCL, red triangles, are they above the red line? The answer to that is yes. Then you're in good shape. You can see this plant here has been above the red line all along. So they've been in routine status throughout their, the last, probably 8 inspections here. Here's an example of the APCC graph. Same idea. Remember, this is the penetration result. So the kind of dark blue triangles, those are the individual sample results. And you've got the calculated APCCs, one for each inspection, connected by a green line so you can see the trend. And again, you're looking to see if that is above the red minimum line, which is at 80%. And you can see again this plant over several inspections has consistently been above the line, even though they do have some individual sample results that are there we go, that are below. It's still their average percent core conformance stayed above the minimum. So here is, this is kind of hard to see, but this is a table, a chart showing how you move from status to status. And you can see here over on the left-hand side, this would be your previous inspection status. Say we were in routine status, which would be the top row here, and your current inspection that just happened, your LCL is above the minimum retention, and your APCC is above, equal to or above 80. So basically, you're above the line on both graphs. And if you trace you go over to that first box and then look straight down, that tells you you're going to stay in routine status. If you go back to that routine status and trace over to the second row, you're going to see here's a scenario where either your LCL or your APCC were below the line. And if you trace that straight down, you'll see that would result in being in increased status. And you can use this chart, for any of those scenarios to help you understand what triggers could require, or could cause you to change to a different status. So in addition to those graphs and the M22, LCL and APCC, there's another standard that defines third-party agency assessment of a plant. This is AWPA standard M23. This standard provides a framework for the agency to review a plant's internal quality control processes. So there's a checklist of various items that the agency is going to look at. Things like, are you doing your daily XRF verification checks? Are you doing retention and penetration evaluations on every charge? And if you fail something, are you properly retreating it? It's an evaluation in a lot of cases of your plant paperwork, your record keeping. There are some additional items, making sure that you're putting a charge number on everything. These are items that, in my opinion, if these things aren't going right, if there are deficiencies with your internal plant quality control, those are going to show up in your retention or penetration results, that the agency samples. So these things, I think, really go hand in hand. And again, this standard has a definition of various point values, and those can result in different M23 inspection statuses. So in this case, you can be in routine status, you can move to warning status, and you can also get disqualified under this standard as well. And in this particular case, a disqualification under M23 would apply to all your production categories, so all of those buckets. M22, like we talked about, is separated bucket by bucket, but M23 applies to all. WQC, that's another, this is the quality control, quality assurance program that is used at some, utility pole producers, and, has some similar elements to, to the AWPA M25 or M22 system, where you're getting these monthly audits, non-conformances are tracked, there's corrective actions that are initiated. This program also has an annual plant qualification, so a review of various M3 AWPA M3 requirements, and it also includes some destination inspections as well. So again, this is a program that comes in on top of your internal quality program, and is looking at a percentage on a monthly basis of your production. Basically, I guess, we talked about sampling, making sure that you're following those prescribed methods in the standard. You're using the proper equipment, make the job easy for yourself. And the sampling process, you want to make sure you're getting a representative, unbiased sample from your charge. That's using that, sampling pattern, not picking and choosing, the boards you're going to core. Analysis, making sure you're minimizing variability in the preparation. So, getting your system, your quality system and your equipment set up so that you're able to be very consistent from sample to sample. You're getting things properly dried, you're grinding it in a consistent way, and you're analyzing it in an XRF that's calibrated and that is right on the money with the calibration. And then if you've got those things in line, then you should be able to predict and have a very good idea of what the agency results are going to be. You know, if you've got your quality system dialed in and you've got your consistent preparation and consistent analysis, and that's dialed in with the agency's consistent sampling and consistent, you know, preparation and consistent analysis, we should be dialed in with each other, and you should have a very good idea of what those, you know, inspection results are going to be each time you get the report. Basically, my big takeaway here is control all the things that you can control. You know, all those little steps in the process, you know, can make a big difference to having consistent, reliable sample results at the end. And you've got my contact info and Tad Clevey. I've included his contact info on here. He is the head of our utility pole division. So if we've got utility pole treaters, Tad would be your contact there. Any questions?
Kelly, we have 2 questions.
Oh boy.
One is, should you drill all in one location or drill at different locations of the treated bundle?
So what you're going to want to do is the best thing to do is to sample all the units in, you know, or as many units in your charge as you can. And you're going to want to have that set pattern. So you may have different patterns for different material sizes, you know, for your 2x6, you know, you may sample, you know, you may skip 2 pieces and drill 1 and then skip 2 and drill 1, you know, that may be different, you know, for 6x6s where you may drill every other one, but have a set pattern, and you're going to drill in the middle of the piece, in the middle of the unit. So each individual hole, you're shooting for that, you know, middle portion of the unit, and you're going to want to drill right in the center of that board. Does that answer the question, or did I miss it?
It answers for me.
Okay.
All
right.
The second question is, does the inspection agency troubleshoot with the treater to help figure out a problem to get back to routine status?
Absolutely. I do that kind of work all the time where, you know, if a plant goes into increased inspection and they're surprised by it, you know, we work together to try to figure out what could be causing that, you know, what could be the cause of the difference, you know, between what you got and your internal quality control for that sample versus what the agency got. One of the tricks I'll tell you guys that I use a lot is I'll ask our lab folks to pull those inspection samples and send them right back to the plant. And then that way you could run those exact same samples we ran on your XRF. And that would be, you know, one of the first things we could use to check to see if, hey, are we even getting the same reading, you know, on this exact same sample? And that's a way to check, you know, kind of calibration comparisons first. And then, you know, if we can check that off the list, if we're reading similar to each other, then we start diving into all those other preparation questions that we talked about. So yeah, absolutely. It's very important to work together to try to troubleshoot.
Thank you, Kelly. I have 2 more questions that have come in.
Okay.
One is, at what moisture content percentage is wood considered too wet to penetrate? 25%, question mark.
Yeah, I think, you know, when you start getting up in those high 20s, I think that's when it starts to become real difficult to, you know, to penetrate the wood. You know, we're talking southern, you know, southern pine here. So, you know, the way I always think about it, it's like, you know, if you've already got your, you know, your bag half full, it's awfully hard to cram, you know, to cram more into that bag. So, so yeah, when you're starting to get into those high 20s, and other folks on the call are, you know, welcome to pipe in, but that's where it starts to get tough for sure.
Thank you. The next question is, we grind our samples and bake in an oven for an hour. I can sample those in our Asoma, then microwave the samples and analyze again. It seems the more I microwave the sawdust, the higher the retention our Asoma gives. Can microwaving the wood samples affect Asoma accuracy, or is the wood not dry enough on the initial sample? If
Yeah,
we
so
then sample these, oh, there's another part. If we then sample these same samples the next day, we also see an increase in retention levels. Our Asoma reads correctly with Lonza supplied wood samples during this same sample period.
So I'll just kind of throw out a couple general thoughts, and you know, this, if there's a specific thing we need to look at, that, you know, we can dig into that kind of offline, but generally, if you've got a sample that has some moisture in it, that is going to read lower in your Asoma or in your XRF. Moisture in the sample gives a lower result. If you have a sample that you have dried and over dried, so scorched it. So if it was, you know, in an oven that was way too hot, or in a microwave that, you know, potentially burned it, then what you're doing is you're burning off some of that wood fiber, but the copper is, you know, or the metal is staying put. So that's going to give you, again, a higher result than what is, you know, actually representative of what's in your wood. So very important that you get the drying part of it right. One thing you can use as a tool to see if you're getting the drying part right is a scale. So if you've got a scale, you can, you know, dry your sample to the point where you think it's dry, weigh it, jot down the weight, put it back, dry it a little bit longer, weigh it again, see if your weight dropped. If the weight dropped, it means you drove some more moisture out. And you know, you may want to dry it a little bit more and see if, you know, get to the point where you've got a constant weight. And then that'll tell you that you've, you know, driven all the moisture out of your sample.
Okay, thank you. From Bruce Horton, it says, might remind folks that treaters can also send samples to Lonza's lab to verify on-site sample results as an added step.
Right. And the other thing I'll throw out there is that our lab and Lonza's lab, we do monthly comparison samples between our two labs to make sure we're dialed in with each other. So that's kind of an additional, you know, consistency step that we go to, because it, you know, all you plants, if you're relying on, you know, on our agency lab or on Lonza's lab to help you dial things in and ensure that you know, your internal quality control is correct. Obviously, it's important that our two labs are dialed in with each other. So, so I can tell you, we've done a lot of work between our two labs, and you know, we are dialed in with each other very well, and we confirm that every month. And, you know, if there's troubleshooting that needs to happen, we do that as well.
Thank you. I have another question for you, Kelly.
Okay.
What temperature do you recommend baking Southern Yellow Pine CCA samples, and for how long to achieve 0% moisture content without singeing the samples?
103 degrees Celsius is your target, you know, kind of plus or minus 2 degrees. And for timing, I'll tell you what we do in the TP lab. We dry cores for 2 hours and we'll grind them. And then we dry the dust for another about half hour. And this can differ from lab to lab. You know, some of it has to do with, you know, with your particular setup. So, you know, you may want to do some, you know, you could kind of use those as a guide, those times as a guideline, but, you know, you may, you know, need to make some tweaks based on your particular setup. You know, think about like a 1-inch core is going to probably take longer to dry than a 6/10 core. You know, if your oven is in an air-conditioned room, you're probably going to have a faster drying time than if your oven is, you know, sitting out in the humid, you know, plant air, because the oven is evacuating the air. You know, it's pulling moisture out of your sample and pushing that air out into the atmosphere. So if it's if it's in a dry air-conditioned room, that's going to happen faster than if it's, you know, out in the, you know, the humid South Georgia weather. So, you know, a lot of things to just kind of keep in mind, that there's not a be all end all. You know, dial it in for your particular plant. And the other thing I'll say about that is, you know, using the scale, that weighing things, that's helpful. And if you have it at the right temperature, you know, so it's not too hot, you're at that 103 degrees Celsius, you're not going to hurt it. I mean, you could leave it in there for a day and it's not going to hurt the sample. So, you know, always better to go longer than you think. You know, make sure you're getting down to that 0% moisture content as long as you're at the right temperature.
Thank you, Kelly. I don't have any more questions that I see.
Okay.
Appreciate you joining us.
Yeah, thanks for having me.
Okay. I've got some things to say before we go to lunch. One is to remind the California participants to respond to the Survey Monkey quiz. And also, North Carolina is requiring us to answer quizzes also. So if you're joining us from North Carolina, you'll be receiving Survey Monkey quizzes also, and you'll need to respond to those. The second webinar begins at 1 o'clock, and you'll need to leave this webinar and then sign in to the session 2 from the invitation you received. That's all I have. Thank you for participating, and we'll get back together at 1 o'clock Eastern Daylight Time today. Thank you.
Thank you, Grady, and thank you to all of our panelists as well. Oh, yeah.
Hey, Belinda, this is Lucy. I just put my phone number in the chat if you want to give me a call.
I definitely will, yes.
Hey, I'm here. Can you hear me? Hello? I can't hear you. Can you hear me? I can't see you. Can you see me?
Hey, Sarah, get off this. We're going to call instead.
Okay, goodbye.
All right, bye. All right, I'm going to close. I'm leaving.